Okay, today's objective is to use variables and appropriate operations to write an equation that represents a verbal description. So it means when we think of a problem or say something verbally, we're able to write a math problem that goes with those verbal words. So if I say, I have $3, but I owe $2, we should all know that we can write 3 minus 2 from that. That kind of an example would be a verbal description of an equation. Okay? So example 1, you're going to write evaluating a function. Okay. Don't write this information about thunderstorms. This is just what we went over earlier in class, but you don't need to write it, okay? Because light travels through air at a much faster speed than sound, you can estimate how many miles you are from a thunderstorm by counting the number of seconds between seeing the lightning and hearing the thunder. So once you see the lightning, you start counting 1001, 1002, 1003. And see how many seconds you count before you actually hear the thunder. Once you hear the thunder, then you stop counting. Okay? So, the distance of the thunderstorm is represented by the letter D. And that is given by the equation, why is it doing that? The equation D equals 0 and 20 hundredths times T, okay, for the amount of time. This is what we wrote earlier. So this is a function. So basically what this means is after 1 second, the storm is 0.2 of a mile away. After 2 seconds, if you get to count to 2, so if you hear lightning, if you see lightning, and then you start counting, and you count to 2, 1001, 1002, then the storm is 0.4 of a mile away. If you see lightning, then you count 1001, 1002, 1003, then you hear thunder. The storm is 0.6 of a mile away. If you see lightning and you count 1001, 1002, 1003, 1004, and then you hear thunder, then it's 0.8 of a mile away. If you count all the way to 5 between the lightning and the thunder, then the storm's a mile away. So basically, every 5 seconds, that storm is a mile away. All right? Example 2, writing a function rule. So, the function rule for this one, this example, this is the rule. Okay? What this means is the distance is 0.2 of a mile or 20 hundredths of a mile times the time. That's how far it is. Okay? And that's this whole thing right here. This whole thing right here is the rule. That's the rule. Okay? So what we're going to work on in the next problem is when you have a function table like this one, and you have to decide what's the rule. You have to think about what is the rule for it. So that's what example 2 is going to be doing. Writing a function rule. So here's the situation. I want you to write letter A, but you don't have to write all of this. You just have to write this. You earn $15 for every lawn you mow. $15 for every lawn you mow. That means if you mow 1 lawn, you get $15. So how much do you get if you mow 2 lawns? All right, you should have said $30. So how much do you get if you mow 3 lawns? You should have said $45. So what am I doing there? What function rule can we write? We can write the rule that if I take $15 and multiply it by the number of lawns I mow, I will get the total amount of money I made. Okay? So we just wrote I as the total amount of money I'm going to make. Okay? All right, and does it have to be I and N? No, it doesn't have to be. Those are just the ones we made up, okay? So don't let the variables fool you. It doesn't matter what N is. You could have chosen an M for mowing. You could have chosen an L for lawns. It doesn't matter, whatever you choose, okay? This is just the example that I'm giving you, all right? So I chose I because that's the input variable. All right? I'm sorry, the input variable is N, and the output variable is I. Sorry. So this is the number I'm going to input, and every time I input that number, this is what comes out. Okay, so if I inputted 2, I mow 2 lawns. Then the output, is going to be 30. If I input 5, I mow 5 neighbors' lawns, right? Then the input is going to be 75. Because 15 times 5 is 75. Right? So, identify the input and output variables. So I just explained that. So I is the output variable. N is the input variable. Okay. Evaluate the function in example 2 when the input is 3. So in other words, if I mow 3 lawns, okay? If I mow 3 lawns, what will the value tell me? So when n is 3, the value of the function, or the output of I, is 15 times 3, because the input is 3. 15 times 3 is 45, so I equals 45 when the input is 3. Now this one we have to write a function rule. I want you to go ahead and write example 4, writing a function rule, find a function rule that relates x and y. So what am I doing to x to get y? What am I doing here? Okay. When there's a 0, I have to tell you personally, for me, I'm going to use a different color here. I like to focus on the 0. Okay? I like to focus on the 0 because there's really not a lot you can do to 0 to get a number. Like if you multiply any number times 0, you're going to get 0. And dividing, you're either going to get undefined or 0. So I know I'm not multiplying because 0 times any number would not be 3. It would never be 3. It would always be 0. So I'm either adding or subtracting. Well, since 3 is more than 0, I think I'm adding. It looks like I'm adding 3. 0 plus 3 isn't 0 plus 3, 3, right? So let's keep adding 3 and see if that works, okay? What's negative 2 plus 3? 1. That works. What's negative 1 plus 3? 2. That works. What's 1 plus 3? 4. What's 2 plus 3? 5. What's 3 plus 3? 6. So that's what I'm doing. I'm adding 3 to my input. So that means I'm taking the x, I'm adding 3, and when I do that, my solution is y. X plus 3 is y, is the function rule. Okay? And it doesn't matter if you say y equals x plus 3 or x plus 3 equals y. Okay? Either way is fine, so you could do it this way too. Y is every number that's in X, I add a 3 to it. Okay? And these both mean the same thing. Okay? We already did that. All right. Let's look at this one. This one kind of applies to us right now because we've been doing so much fundraising. Your class is hoping to sell 200 magazine subscriptions to raise money for field trips. Your class earns $3 for every subscription sold. Explain why this situation is represented by the equation I equals $3 times M. Okay, so the way we would explain that is just to say every time we sell a subscription, we're going to increase this number M and multiply by 3. So if we sell, let's say M is 2, we sell 2 subscriptions. $3 times 2 is $6. So then I, the output, would be $6. Okay, the input would be 2 if we sold 2 subscriptions. Okay, you don't have to write anything for this, I just wanted to talk about that one. But now you do have to write number 2. Identify the input and output variable of the corresponding function. So, M is input, I is output on the previous screen. So, what does that each represent? M is the number of subscriptions sold I is the total amount the school gets, because we get $3 for every subscription sold. Okay? Find out how much money your class earns when 50, 100, 150, and 200 subscriptions are sold. And then organize your data in an input-output table. So you're going to draw the input-output table, write all the information so you know what you're doing. Draw the input-output table, draw this whole table, and then just fill in the numbers. So our input numbers are, let's see, it told us we sold 50, we sold 100, we sold 150, and we sold 200 subscriptions. So you don't need these 2. You can do 2 less than I did. I did 2 too many. Okay? So now how do I figure out what's the output? How much money did I make? Well, every time I sell one, I make $3. So $3 times 50 here. $3 times 50 is 150. So here I make $150. How about here, if I do $3 times 100? Then I would make $300. What if I do $3 times 150? Well, that would be $450. And $3 times, 150, times 200. Well, that would be $600. Okay? The distance d that sound travels in seawater equals 9/10 of a mile per second times the number t of seconds. Write an equation that describes the distance traveled in terms of time elapsed. So, I'm going to take the 9/10, I'm going to multiply it by the amount of time in seconds, and that is going to equal the distance, d, traveled. Okay? So, here's my, I was right, here it is. And evaluate the function when t is 30. So now we're going to use substitution like we did today in class. D, I don't know what that is. 0.9, I know what that is, and t is 30. So I'm going to replace the t with the number 30, and then I'm going to multiply to get d. 0.9 times 30 is 27. For those of you who need to see it, 30 times 0.9. 9 times 3 is 27. I've got one decimal, 27.0. All right? Find a function rule that relates x and y. So, again, I'm going to start with my 0 because that's the easiest one to start with, right there. What am I doing to 0 to get -4? Again, I'm not multiplying or dividing, or my number would be 0. So I must be subtracting, because 0 minus 4 is -4. So let's try that. What's 1 minus 4? -3. What's 2 minus 4? -2. What's -2 minus 4? -6. -1 minus 4? -5. So that's correct. I'm subtracting. So y is x. You could put plus -4 or minus 4. So you could do plus -4. Let's see if that catches up. Ah. Or you could do x minus 4. Either way, it means the same thing. Okay? All right. That's it. You guys are done. Have a great night.